So today we will be talking about something a lot of talks before this have covered, but we will take a different angle to that. So we're talking about investing in multi-tenancy. So before I start, one question: how do you consider the concept of multi-tenancy? We have such a good audience today. I could explain how, but we'll start from scratch. So a bit about me, I'm Hrittik Roy. I'm a platinum manager at LoftLabs, senior ambassador of Google Reddit Forum. So I've done a couple of certifications here, a couple of talks. And before I start about multi-tenancy, I want to explain and touch a bit about Kubernetes, the complexity and cost now. So Kubernetes, whenever we talk about Kubernetes, it comes into the picture as a way to abstract away complexity. It's a complex way for software that uses more complex things to abstract the complexity of managing nodes and all those things, different geolocations. Apart from the complexity of things, it also abstracts the cost. The reason it abstracts the cost is because you don't need to care about how much your nodes are costing and all those things. Everything is abstracted by a single pane of view. And when we talk about cloud and Kubernetes economics, so Kubernetes is a large-scale distributed system can range across different geolocations and different nodes, different categories of hardware. And what is now computing company, the node is a revenue generator, as well as each cluster is a revenue generator. So most of the cloud companies are focused on increasing their revenue by improving the developer experience and simplification of cluster creation. So whenever we talk about nodes are the actual teams and all those things. So it helps to generate revenue for cloud providers. That is 24 team costs is for each of your cluster. So whenever you create a cluster in you have to pay your networking cost. So it's somewhere or more. So the problem is not that it's easy to create a cluster. Problem is it's too easy to create a cluster. A lot of companies are just creating cluster after cluster after cluster. A cluster for each customer, a cluster for each developer, a cluster for your environment. And the cluster creation takes time, as well as cluster creation and management is a different process altogether. So you might have ending up with 100 unnecessary cluster. So what happens is like when you have a cluster, the first problem is the cost, because all of the control plane is running all of the rules already. But the second problem is maintenance, security, life cycle, and all those things as well. So how do you take care of all those things? All those thousands of unnecessary clusters. So we need to go about what are the costs of the cluster before we dive deeper. The first is the cost to run your applications. And the second is the cost of the cluster and their search stack, which can be your digital tools like a search manager and all those things. So whenever we talk about the cluster configuration, there are two things. First, we want you to make cluster easy, but again, we want to be sure that we are not spending a lot on hardware and stuff, and our sustainable business costs. So the goals are generally about saving costs while reducing the complexity of creating, deleting, and managing your clusters, improving efficiency for your teams. So developers are one of the most expensive resources in team, and you want them to be efficient. So you don't want a developer to wait through the IT to get a cluster. You want that to be faster and smoother. And lastly, a lot of sustainability concerns are there as well. We want to be there where we are reducing the carbon footprint and as well as improving the overall cost. So whenever we talk about multi-tenancy, multi-tenancy is your business unit, your customer unit, or application unit. So it's like a lot of tenants together. So if you want to understand more about multi-tenancy and all stuff, let's take examples of our home. So generally, whenever we say we have a same home or flat, So in homes, what is the thing is like you can have one tenant, person who is the owner, and the other tenant is your renting. But again, everything over there you are managing on your own, including the plumbing, the security, the electricity, and all those things. On the other hand, there are flats where you have a lot of shared space, a lot of people living together. Each of them have their own security key cards, so they can access the foreign as required. As well as there is other things like electricity and all those things are managed. Right. So I think there are two types of ways we can take other resources and all those things. We can extract that way. So the scope is like as human scales quantum plans and normal plans. Whenever we talk about multitenancy in the spectrum of facility systems, we try to focus on how we can share space or share a cluster across different tenants, which can be within an organization, like a different departments, or outside an organization, like a different customers who want their dedicated space inside because of compliance and security. So whenever we focus on the balancing act, like what you want to have just enough infra while having maximum cost efficiency and share everything, like a share space and all those things, so everyone can have a flexibility to deploy and use whatever is running. Or you want something with multiple infra deployments for different tenants with limited provisioning and tied experience. So each of them has a way to experience the type of hardware they want. For example, you don't want a tenant to use GPU when they don't require it. Just having any sort of covenant. So with that, if we go back to the pure community concept and everything, there are two forms of tenancy. One is hard tenancy, one is soft multi-tenancy. In hard multi-tenancy, you focus on creating individual clusters of each of your tenants. In soft, the thing changes because we have a key Kubernetes object called namespaces. And when we focus on namespaces, tenants usually are in the same organization and we can allow them to create whatever they want. It's a couple of objects like your custom resource definitions because they are across the level. So because this is one in Kubernetes, there is a creating namespace for clusters. So now why do people care about multi-tenancy overall? First is cost savings. So if you can share a space, share a hardware, share anything altogether, you're saving on cost. This is complexity. Having a lot of things moving is hard to manage and all stuff. So if you have something shared together, it increases your a level of complexity for the admin, but generally develops for regular themselves. And lastly, one of the things is whenever you focus on multi-tenancy at all, there was isolation. So if you are sharing a room between your friends and there are a lot of rooms. So you need to have isolation between that, right? Even if you are staying in rent for somewhere. So it's similar for your cluster sample and applications running over there. So you need to ensure isolation between that. And lastly, availability is also important. For example, you are sharing a cluster within three companies and one of them company has a ready issue or a plug file, which one of the clusters can be affected. That is not experience you want to have. You want to have that isolation and so that any of the tenants behave or misuse the services they are getting. That doesn't override and overburden the other tenants. And if we think about the mainstreams of multi-tenancy, so the limitations there are like your security considerations for persistence, volume, and all those things. Next is the noisy level problem. For example, if you are creating thousands of objects on the go, there might be an issue that your EPS server and HTTP has a bottleneck, which causes your application to crash as well as entire cluster to go down. Like one of the events which happened in 2022 with OpenAI was they had a new telemetry service which was creating a lot of load. So it caused the HTTP to go down, causing the entire stack, the API is small and all the stacks will go down. The last is with namespace is the other problem is like CRD. So CRD is all custom level objects. So they are not a namespace level object. So when you have custom resources for your specific team, it's not possible to have different versions. You think about the version you have. If you want to open a quick game, right? It's hard to figure out accessing and access that you want. You want to give access to any to one of the you can need to decide. It is not optimal, right? Because access to second hand and as the complexity grows, it's like when there's shared ingestions and all those things, different things can have different costs and requirements, so it might be complicated. And last is whenever there are teams, there must be a complex billing requirement. Each tenant should care about building their own services in bullet form, so that might be hard as well. So when we talk on the other side of the spectrum, which is going different house for each of your tenants, there is clusters, but the problem with clusters is like there are a couple of costs associated with it. One is the control gate cost, which is an unnecessary but a necessary cost that you pay for each of the cluster you are creating. Then there is the cost of running platform stacks. Suppose you have 100 clusters, and all of them are using a search manager or ingress controller. You deploy that 100 times. So to compute the memory and the storage required for that is 100 times. You can have them using once in the instance one. And then there's the cost of running workloads. Like management there is hard for this type of architecture when you have so many clusters. So to manage the updates, and all those things, it's just hard students with their view across all of them. And really also kind of handle the capacity with that. And now this distribution becomes complicated as the number of clusters, number of users you have, you need to have that, so there is quite high cost. So if you want to just compare the namespace of the cluster multitenancy form, there is five different areas. Application access cost, resource sharing and overhead. And you see there is separate namespaces which are simple public object. You get pretty deep access because of the identifications and all access for tenants. But when on the other cluster side, you get the strong isolation access for tenants is strong as well. But your cost is high, so sharing is complicated because you download it by the same resource again in the different clusters. And there is all has because you need to maintain different delivery and update cycles for each of your clusters. So if you have the option to choose any of them, what will you choose? Will you choose namespace or cluster according to your multi-tenancy strategy? So what we are working on is something called virtual clusters. And whenever we talk about multi-tenancy virtual clusters, it is a middle layer in which you focus on isolation, access, cost, sharing, all and again, but you get the both of the board the whole. For isolation, you get a stronger isolation. We will go down to the architecture in a bit. Then by focusing on access for tenants and all those things again. And resource sharing and overheads are low because you are using virtual clusters. So you focus on the architecture. So there is a popular open source project with a lot of companies using it. So before we go down to the architecture of the three cluster, it's a certified tooling distro which allows you to create virtual clusters and create virtual machines. And bringing your own hardware, which can be a bare metal, which can be a cloud Kubernetes cluster, and then you create games on top of it. You can similarly create a virtual cluster on top of that. And the benefits, like you don't need to wait 45 minutes to deploy this, you can wait 20, 30 seconds. And these are the virtual clusters you have full admin privileges on that. Even if you don't have admin privileges on the host cluster, so the advantage is you can do whatever you want to inside it, you can custom tests and all those things. And then the other advantage is that you can isolate and see resources. Suppose you have a rest controller in the host, and you want to see your ingress classes from the host to all of the virtual clusters. Or, for example, the policy of the host cluster. And you want to be making sure that each of the cluster you create in the life cycle of each of the developers, they follow those security practices which are defined by the time in the policy. You can do that usually. And of course, your developers can get those clusters in a quick way, which is kind of key. And let's go into the architecture. So the way virtual clusters work is like, as in here, you need to have a virtual layer or hypervisor. So here you bring in the Kubernetes cluster. And the Kubernetes cluster can be a host cluster in the cloud, it can be a bare metal, it can be anything you want. It just needs to be a Kubernetes cluster. And then we use the CLI or the platform to create virtual cluster. So some of the concerns which generally have performance. So what we do is like we API server, which manages all of your load that is in the virtual cluster and it goes to that. So there is no actual load on your host, but you get the isolation because everything is going to the API server which you have created. And then suppose you are creating a pod or any object, this things to the host over here. So, for example, if you create a pod, stick to the main host, so everything is running in your actual infra. So there is no latency, there is no performance degradation. But you get the advantage of isolation between different tenants and system host factor. This is one example. But for example, if you are running three teams, so you can have three virtual cluster tenants for each of your team products there. So anything like that or some type of testing environments. So each of your developers can get a quick Kubernetes cluster without waiting for it. Other thing is like, for example, you can talk a lot about platform stack and platform cost. So the other advantage close to the picture, like for example, you're running Argo, Voice, Manager, and all those things. So you can combine them together in one host. And each of the time you create a virtual cluster on host cluster, you can consume the REST controller and Vault and all those things. You don't have to go in and deploy each of the time. So everything is free if you wanted to, and if you don't want it to, you can go and deploy it again. So you have the flexibility to do whatever you want. Lastly, it means you have to figure it out. Like why this is so important. So as we have a lot of clusters running eventually, so there's a lot of problems with how many clusters you're running. Maybe in the platform stack, the cost of running the control plane. So using a virtual solution like virtual cluster helps you to give the overall cost because you don't need to do and deploy things again and again by seeing the platform stack and control plane cost just get consolidated into one. And what are the key use cases which we can think about when we think about virtual clusters? So generally, when you have CI pipelines, we can install a lot of things and everything. So one of the use cases is like CI and CD because you can create a virtual cluster in a couple of seconds and it can consume everything that is in your host, so you can isolated fresh environment where you can run your cache. Next is everywhere caching environment. Environment with different CREs. When you are building an operator on CRE, you can use something like this because with that, each of your virtual classes can have different CREs, and with those CREs you can build and deploy different operators. And lot is very secure easily. For example, starting details are very complicated challenge. So if you're using price scheduler and all those things, you can use this across your different tenants. So integrate others can consume a part of each queue. So I think we have time. So what we do is like we just go and see a simple demo right now. And for that, you can all of the things that you can plug in just use video of it. And you can the isolation best practices and all those things. So what we do is like we just do that. So to create the feature, you can scan this QR code and we give you a couple of seconds to do that. Yeah. And we'll just go and create quick features over there. With links for the okay. So yeah, already have a medium cluster running. So we have the CLI or the lot of information. So we'll just keep it up, get the cluster and just move it fast. So we need the name is so everything. So first you will go and download the API server and create an interface. And after that, what we will do is we will create the single pod, which is the API server. So it will take a couple of seconds. So what is what we can focus on is checking how things are working. So it's about that. So now we press the pod and try with the immediate containers are running. It will take a couple of seconds. Okay. So when virtual cluster is created, there are two components to it. Users are created in the host to store everything which they are running. So that we have a activation on the host level as well. And this is the area the pod which that is also the request. So generally the one that is create a name and automatically and then it continues runs and sees that everything is working as it's like to control automatically. Like a couple of seconds will have for virtual cluster and let me see the virtual cluster is running. So it keeps to see that know going to project. So it is taking a note from propose the virtual application of the next or again on how this content being created has to go to the host cluster, which is solution and that is so in the whole cluster, we are creating the next or theory, putting in the implementation that and we discussed before whenever we create something on the machine that back to the host. So you have the result. And this thing you can use for not just your CPU workload, but your CPU workload as well. Like if you have a lot of nodes, CPU nodes, you can share it with your different virtual clusters, different operating platforms. Rather than there's a fact you want to join, that has more or message, you can reflect on can connect with me here and here after any questions after this talk. So this is the connect with me. And thank you so much for having me over here.